Rectilinear motion. What means that? That's just one-dimensional motion along a line. Hey, that sounds like something we do in physics. So with apologies to any students who are not in physics or especially AP physics, because we have already done the stuff of this. So this is just like a calculus look. We already know that calculus applies. We've already been using it in physics class, so no big surprises here. Let's do these problems and see how it goes. That's the chapter. There we go. All right, so starting with number 1, what do we have here? I've got position functions, and we want to know in each case determine the signs of the velocity and acceleration and determine whether the particle is speeding up or slowing down. So first one, I've got a graph that looks like this. So remember, velocity is the first derivative if this is position versus time, which they're telling us it is. The velocity is first derivative and acceleration is second derivative. So is the first derivative positive or negative? It's positive because this is increasing. Acceleration is the same as the second derivative, or the concavity. This is bending down, part of a sad face, so that's negative. And if these two signs agree, then you're speeding up, and if they disagree, you're slowing down. For the second one, I've got V. This is increasing as you read left to right, so that's positive, and it's also bending upward, part of a happy face, so that also positive, which means we are speeding up. And then I've got this, where V is negative, but A is positive. It's part of a happy face. It's concave up, part of a cup. And they disagree, so that means we're slowing. That's it. Number 3, you got another graph to look at here. We want to know, is the particle moving left or right at time t sub 0? Well, at time t sub 0, the position is decreasing. I'm just looking at the graph itself. So the position is decreasing, which means it's moving to the left. Is the acceleration positive or negative? At time t sub 0, it looks like it's bending downward. Looks like it's part of a sad face. Not quite. It looks like it's almost close to being a point of inflection where it changes from bending down to bending up, but I think they want us to think it's a little bit before that point of inflection. So if it's bending down, then the acceleration is negative. For part C, is the particle speeding up or slowing down at time t sub 0? Well, if it's moving left, that's the same as saying if the position is decreasing, that's the same as saying the velocity is negative. So if those are both negative, then we're speeding because they agree with each other. Is the particle speeding up or slowing down at time t1? So at time t1, what's the velocity? The velocity is, the position is decreasing, so the velocity is negative. In other words, it's going down, the slope is negative. And the concavity looks like it's concave up, so that means it is slowing. All right. And what's next? Number 13. All right, a lot of things we're supposed to do here. We've got a position function, and units are feet and seconds for position and time. We want to find the velocity and acceleration functions. Our book likes to use S for position in your physics. If you're in AP physics, we usually use R for that. Our position. So that's, and they're talking about here only times that are greater than or equal to 0. So the velocity would be 3t squared minus 6t, and the acceleration would be 6t minus 6. Okay. Find the position, velocity, speed, and acceleration at time 1. So the position at time 1 is 1 minus 3. The position, the velocity at time 1 is 3 minus 6. The speed, I don't want to use an s, obviously, at time 1. Speed is the absolute value of velocity. And in one dimension, that just means make sure it's positive. In 2 dimensions, you got to think about Pythagorean theorem, right? But not in 1 dimension. And then acceleration at time 1 is 0. All right? Part C. At what times is the particle stopped? The particle is instantaneously has a velocity of 0 when the velocity equals 0. So let's see. How about we factor out a 3t, and then we get a t minus 2. So it looks like at t equals 0 and 2, which are both legit times, that's when the velocity is 0. Part D. When is the particle speeding up and slowing down? To find speeding up and slowing down, you really need to know the velocity and the acceleration. So this is what I'm going to do. I'm going to find the zeros of the acceleration. That's pretty easy to do. That's at t equals 1, at time 1. And then I'm going to make a little sign chart. I'm starting at 0, so I don't have to make an arrow going that way. And then I'm going to put all the zeros for velocity on top and acceleration on the bottom of this line. So velocity is equal to 0 at 0 and 2, and acceleration is equal to 0 at 1. And then I'm just going to check the signs of these. So the velocity, when the time, checking a point in between here, like I could check 1, for example, plugging 1 in here, I get a positive times a negative. And then plugging something positive in here. There's no squared factor, so we know that's going to change sign. As we go across there, you can test something if you want. And then the acceleration goes from negative to positive as it crosses over 1. You test points if you like. So now I can see the intervals of speeding up and slowing down. So here, from 0 to 1, they're both negative. So I'll do this as a little table. From time 0 to 1, we are speeding. From 1 to 2, we are they disagree with each other, so we're slowing. And from time 2 to forever, we're speeding again. So this is just like a sign chart with the first and second derivative, right? Same idea. Actually, not just same idea, it's really exactly the same thing, isn't it? Number 17, same directions. So let's see, for part A, I want to find, hold on one sec, sorry. Let's write this down first. So for part A, I want to find the velocity function. That's the derivative of this. Let's see, product rule. So derivative of the first times the second plus the first times the derivative of the second. right? Better simplify that some. So let's see, what do we have in common that I can factor out? Looks like the only thing I can factor out is the e to the negative t over 3. But you know, I'm not super crazy about having that negative 1/3, because then I'm going to distribute that. So I'm actually going to factor that out too. I'm going to factor out to the front negative 1/3 t to the e to the minus t over 3. Now, you might be wondering to yourself, okay, I see where you're going there, McGrath, but you can't factor a negative 1/3 out of 2. Of course you can. You could just dividing. So if you divide out a negative 1/3 from 2, you could think of it as what's the thing that would have to be here such that when I distributed, I would get that. Well, it would have to be a negative 6t, right? Because negative 1/3 times negative 6 is 2. You're just dividing by negative 1/3, same as multiplying by its reciprocal. And the reason I did that is now I just have plus t squared plus 8. And that, if I rearrange that, looks like it might even factor or something. Struggling here to make my pluses and my t's look different. All right, that would be my recommendation there. And now, hopefully that makes finding the acceleration a little easier. So let's see, derivative of the first times the second plus the first times the derivative of the second, which would be what, 2t minus 6. Okay, so let's see if we can do kind of a similar thing here. I'm going to factor the whole, this is 2/9 here. Sorry, 1/9 when I multiply those two together. So let's factor that out. 1/9 e to the negative t over 3. That will make this just stay the same. And then what would you have to have here so that when you distributed the 1/9 you got negative 1/3? You'd have to have a minus 3 there, right? I factored that out to the front, and then my 2t minus 6. That's some creative factoring, but I think you're going to see when we go to find the zeros of these things, if we try to do that without a calculator, then it's going to be much easier because of how we did that. All right, part B. Got to find all the stuff at time 1. Position, when I plug 1 in, is 9e to the negative 1/3. And the velocity at time 1 is negative e to the 1/3 over 3. That's that number. Times, when I plug 1 in this, I get negative 6 plus 1 is negative 5 plus 8 is 3. That's negative e to the negative 1/3. And the speed is just the positive version of that. Now we want to make sure that we're reporting a positive number, and e to the anything is a positive number, so that is the positive version of that number. And the acceleration at 1 is e to the negative 1/3 over 9. And then, I guess I should have simplified that. Oh well. So that's, let's see, I plugged 1 into this already. That's 5, right? 1 minus, isn't it? Minus, yeah, 1, no, it's 3. What? Oh, yes, 3. Why did I get the 5? I don't know. There it is, right there. 3 minus 3 times, then I plug 1 in here, I get negative 4. So that looks like 3 plus 12 is 15 over 9 is 5/3 e to the negative 1/3. All right, this one's more fun than 13, huh? Let me check answers that we have so far to make sure that we are okay. I think that we are. Looks good. Part C, we want to know when the particle is stopped. So that's when the velocity is equal to 0. So take the velocity and set it equal to 0. Well, this whole first little bit here, like, that's just a number. That can't be equal to 0. This, e to the something, that cannot be equal to 0. So the only part that matters is this. And that factors to t minus 2 is t minus 4. So we're looking at times 2 and 4. That's when the velocity is 0. Now, it doesn't mean it's stopped. It's just instantaneously. Those are places where it's either turning around or it's just momentarily coming to velocity 0 and then continuing on. Just like we have maximums, minimums, and those like, oh, just kidding, where it was like going to be a maximum, but then it flipped up, like the x cubed function. That's what we're looking at here. D. Speeding up, slowing down. Well, I got the zeros for that, so how about for the acceleration? What about this? Acceleration is equal to 0. So 1/9 e to the negative t over 3. This is always positive. And then what do I have on the inside? I got t squared minus 6t minus 6t plus 8 plus 18 now I think that that's what we have there, and doing a little bit of math, that's going to be equal to 0 at, that does not factor, so that's going to be, oh sorry, acceleration equals 0 at t equals the opposite of b plus or minus the square root of b squared minus 4ac. Let's see, that's 104 over 2a. So let's see, that's the 40 under there. The square root of 40 is 2 square roots of 10. I can divide this out, so 6 plus or minus the square root of 10, looks like. Are those both positive times? The square root of 10 is like 3 and change, so 6 plus that or minus that, those are both legit. So if we want to know about the speeding up and slowing down, velocity, acceleration, I've got the velocity is 0 at 2 and 4. And then, let's see, 6 minus the square root of 10, that's kind of like 3-ish, so it's here. And then 6 plus the square root of 10 is going to be up here. Right, so I need to figure out what's going on with the signs here. And you got to be careful because with the velocity, I have something that's always negative here, and then this is an upward opening parabola. If it was just this, then it would have to be plus, minus, plus. But this is going to switch it to minus, plus, minus. You can go ahead and plug in numbers if you want. You just have to remember that this is always going, there's no point in plugging anything in here because that's always positive. E to the anything, positive, so this makes that outside negative, and then you can test points in here. For the acceleration, I think I have a similar consideration where I have this is always positive, and then this is an upward opening parabola, so this must be plus, minus, plus. All right, so what would it look like if I made the little chart here? Maybe I can just point to the intervals. I'm running out of space here. So here, from 0 to 2, we are slowing. From 2 to 6 minus the square root of 10, the two signs plus and plus. So I'm speeding. I think it's just going to alternate, right? Because my signs are properly alternating everywhere. And then 6, sorry, that's very judgmental for me to say that that was proper for your signs to alternate. Who am I to say? Slowing, and then here from 4, 6 plus the square root of 10 is speeding because they're both negative, they agree. And then from 6 plus the square root of 10 to infinity and beyond. We're slowing again. Oh, slowing down forever. That's kind of sad. All right. Quick peek at... Oh my goodness, I forgot to do a part of 13, didn't I? I forgot to do part E. I'm going to have to go back and do that. Let's see. So part E for this one, find the total distance traveled by the particle from time 0 to 5. So let's see. From 0 to 5, if I want the total distance traveled, then I need to know what's going on. I need to look at the turnaround points here. The turnaround points are going to give me the two different legs of the journey where it's going here backwards and then forwards again. So what I need to do to find that total distance is figure out what is the position at time 0, what is the position at time 2, because that's my turnaround point, and what is the position at time 5, because that's the end of the interval. So let's see. Position at time 0 is 0. Position at time 2 is 8 minus 12. And position at time 5 is 125 minus 75. And then here you got to be careful that you're really counting everything. You want to look at each leg of the journey. This is total distance, so everything's positive. 0 to negative 4, that's covering a distance of 4. Negative 4 to 50, that's covering a distance of 54. So total distance covered, total distance traveled is 58. All right, let's do that for number 17. Where are my turnaround points? Same interval from 0 to 5, and the velocity is equal to 0 2 times in there. So we need to find position at 0, position at 2, position at 4, and position at 5. And I can plug those numbers in to my position function, but except for at time 0, where I'm going to get, let me move this here so you can see it, where I'm going to get e to the 0 here, which is just 1, so that's just 8. The rest of these are going to be some kind of nasty looking number because I'm going to have e to these fractional powers. So I don't really see any advantage to doing that without a calculator, and I certainly wouldn't ask you to do that on an assessment without a calculator. So here, let's find those values. I'm going to go ahead and put the function in here so I don't have to keep retyping it. X squared plus 8 times e to the negative, oops, that's a minus sign, negative x over 3. Let's make sure that looks good. It does. And then I'm going to go to second, calculate, and get some values. So the first thing I want to plug in, I guess I could plug in 0 just to check. There it is, 8, so we didn't mess that up. And then plug in 2, and we get 6.161, rounded correctly to 3 College Board decimal places. Plug in 4. You could also do this in the table. I bet you know how to do that. And plug in 5. Not moving around much there, is it? Okay, and then a little bit of math left to do to find how long each one of those journeys, legs of the journey is. So what's going on there? 8 minus 6.161. And then I've got 6, let's see, which one of those is bigger? Not that it matters, I'm just going to make it positive anyway. 6.326 minus 6.161. If you did those the other way and you got a negative number here, you just strip off the negative sign, because we're looking for distances here. And then 6.326 minus 6.233, and then add those up. So I've got that one plus that one plus the first one all right. And looking back at the answer that they have, that is not the right answer. Not according to what they did. So I don't know if I plugged something in wrong. I don't think that I did. But I'm going to leave that. And if I did do something wrong, then x squared plus 8. Then I apologize. I don't know what I did. I think I just plugged those numbers in. Thought I did the right thing there. So we're going to leave it at that. Okay. What's next? 29 and then 35. 29, we want to, it says, give a graph of f, identify the limits as x. What, did I flip too far? Oh yeah, I got all the way into the review exercises. Just kidding. Number 29, we've got a position function. S of t is 5t squared minus 22t. And that's our position function, moving along a coordinate line where s is in feet, t is in seconds. We want to find the maximum speed of the particle during the time interval from 1 to 3. Okay, now you got to be careful here with maximum speed, because speed is the absolute value of velocity. So if you imagine your velocity function, I'm not saying that this is what it looks like for this one. But if you imagine a velocity function that's doing whatever, the absolute value, the speed, would be this, except every single thing that was negative would get flipped up into the positives, which means the maximums of the speed could be the maximums or the minimums of the velocity. Because if we get a minimum that's like a really big negative number, the speed is the absolute value of that, right? So we got to check the maximums and minimums of the velocity. So what's the velocity? It would be 10t minus 22. Where's the maximum of that? Or where is that equal to 0, rather? So, oh, wait a minute. No, we won't find the maximum speed, so we need to check the maximums, minimums of this. If we want to check the max min of this, you need to find the derivative of this and set that equal to 0. So I need to do that. Right? If you're looking for the maximum minimum of the velocity, those are places where the acceleration is 0. And this acceleration is never 0, so where does that leave us? Well, that means we have to check the endpoints because we're doing this on a closed interval. So what's the velocity at time 1 and time 3? If I did find some zeros, I would include those in this table, but I didn't. So what's the velocity at time 1? It's negative 12. What is it at time 3? It's positive 8. So the speed is the absolute value of this, so the maximum speed is 12. Part B. When on that same time interval is the particle farthest from the origin, what is its position at that instant? Okay, let's think about that for a second. How would we do that? If you think about your position versus time graph, the candidates for farthest from the origin are places where the velocity is 0, the turnaround points. And then you just have to see what the position is. And just like with this absolute value here, farthest from the origin could be farthest right or farthest left from the origin as it's moving back and forth. So we would have to check maximums and minimums. So let's see. Max distance from the origin on that same interval 1, 3. And we will check the endpoints because we're doing maximum on closed interval. So now we want to check the maximums and minimums of position, which means that I'm going to set the velocity equal to 0, and that's going to happen at 2.2, which is in that interval. So now I need to see what my positions are at, oh, we did those backwards there too, sorry. At 1 and 2.2 and 3. Checking my positions. And I'm not going to make you do 2.2 squared without a calculator. I guess I can get 1 and 3 pretty easily here. Am I looking at the right? Yeah, it's still this, isn't it? So that's 10 minus 22. Sorry, 5 minus 20. Where did I get the 10? Oh, I got it from here. Got that stuck in my head. 5 minus 22 is negative 17. And when I plug the 3 in, I get 5 times 9 is 45 minus 66 is, I think that's negative 21, right? Math. And then I have 2.2 squared times 5 minus 22 times 2.2, negative 24.2. So they wanted to know when is the particle farthest from the origin. At 2.2 seconds. And where is it? Or what do they say? How far do they want to know? What is the position? The position is negative 24.2 feet. What they said? Yep. Let me check those answers. See how we did. Looks good. Yep. And last problem from this section is number 35. Let's see. Suppose that the position functions of two particles P1 and P2 are those things given there. Prove that they don't collide. Well, if they're going to collide, then their positions would have to be the same at the same time. So let's see. If I set them equal, you set the positions equal to each other, and try to solve, and find that there's no solution to that. That should do it. It's supposed to be squared there. Sorry. Plus 1. So that's 3/4 of t squared minus 2t plus 2. And I'm going to multiply that through by 4 so I can get a better idea of what's going on there. And this has no solutions if the discriminant is negative. So I'm just going to check that b squared minus 4ac and see if that's positive or negative. So that'd be 64 minus 4ac. That's negative. So there are no solutions to that. Well, they have i's in them, but that's not a solution. You can't have a time with an I in it. So I think we've done part A. We proved that if you set the positions equal, there is no time when the positions are equal. How close do they get to one another? Well, what's the distance between these? You don't have to use the distance formula because this is just one-dimensional. If this is the position of one and this is the position of the other, the distance between them is just the absolute value of subtract them from each other. You know, I think that's what we just did here, right? So let's take the distance between them is this. Although I'm not putting absolute values, so this could be a positive, negative. The positive, negative distance between them is that. And we want to know how close they get. So when is the distance between them at a minimum? So the distance between them at a minimum. So let's see, that would be 3/2 t minus 2, and that's equal to 0 when t is equal to 4/3. But they want to know, we want to know how close do they get to each other. So let's see. That, if I plug that in here, this is that positive, negative distance between them. So plugging 4/3 in here, that gives me 16/9. Well, one of the 4/3 can say, I guess it just goes as 4/3, doesn't it? Because one of the 4/3 cancels the 3/4. Minus 2t plus 2. So that's minus 4/3 plus 2 is 2/3. So they get 2/3 of a foot from each other when they're at their closest. Check that. Make sure I'm telling you the truth. That is the truth. And then part C of this problem During what intervals of time are they moving in opposite directions? All right, well, I think I can do one of my little sign charts. Excuse me for moving up here, where I have room. So let's see. I need to know the velocity of each one. So the velocity of particle 1 is t minus 1, and the velocity of particle 2 is negative 1/2 t plus 1. So that changes sign at 1, and it changes sign from negative to positive. And this changes sign at 2, and it goes from positive to negative. So what did they want to know? Moving in opposite directions. So they're in opposite directions when they have opposite signs. So from zero to 1, here they're both going in the positive direction, and then from 2 to forever. All right. That should do it.